Hi, my name is Mel, and I am going to do a very basic sort of introduction to digital forensics and computer forensics. And I am very, very far from being an expert. I'm just about to finish my diploma of cybersecurity. I might be going into degree of cybersecurity, but I'm, yeah, very, very far from being an expert. So this is my best understanding of the education I've been given so far. So, digital and computer forensics is the preservation, the scientific preservation, identification, extraction, and documentation of digital evidence that can be used in a court of law or corporate investigation. So, computer forensics can specifically target things like endpoints like laptops, desktops, and servers. Digital forensics serves as a broader umbrella encompassing networks, mobile devices, IoT, and cloud infrastructure. So there's some really basic definitions that can come into account. Like first, I guess it could be a golden rule if you want to call it like this. Never ever analyze the original evidence media directly. Always create several, and I mean several more than one, as in 2 or 3 copies, and analyze the copies instead. All right, so whether that's a hard drive or RAM or USB or SSD, examine them, copy them, and examine them. You can create a disk image, you can create all sorts of things you can do. You can create media images, I would do that. Okay, chain of custody. Meticulous log documenting everybody who collected, handled, transferred, or analyzed a piece of physical or digital evidence with, like identification, signatures, all that sort of stuff, time dated, everything. Any undocumented gap can render evidence legally useless and fundamentally probably useless elsewhere. Data integrity via hashing. Cryptographic hash functions like SHA-256, which I would use SHA, not MD5, but anyway, are used to generate a unique digital fingerprint of the original drive. The exact same hash must be generated from the forensic clone. Any mismatch meaning the data was altered, invalidating the investigation. And like by checking hashing too is a way you can see if a file or a log has been interfered with or changed. All right, so you can check hash values to detect that. So, what is the standard forensic process workflow? Okay, so first of all, collection acquisition. So you got to collect all the information. All right, so this you would probably collect any volatile information first. By volatile, I mean RAM and other information. Okay, RAM is random access memory, which like is local computer or server RAM. As soon as there's any kind of power off, that information's gone. If you reboot the system, you've lost it. Okay, so this is really vital that if someone detects like malware or anything else, don't just reboot the system because we need to see one, how the virus is acting. We will need to isolate it, obviously, but we need to check the memory and other sources of information on that particular system. Okay, we need to get log files because they're subject to change too. We need to get access to any media. All right, we need to all sorts of log files from all sorts of devices, endpoint log files, network log files, application log files, security log files, auditing log files, you name it. Okay. Investigators use physical hardware write blockers to prevent the analyst machine from modifying the evidence drive during the imaging process. And that is really crucial. Okay, so then you need to do examination, like combing through the raw data to extract hidden or obscured information This includes carving out files out of unallocated disk space or parsing hidden system logs. Then they need to do analysis, correlating the extracted artifacts to reconstruct as best you can a timeline of events. The analyst hopefully answers the who, what, when, where, how, and why of the incident. Reporting, creating an objective, exhaustive technical document explaining the findings comprehensively. Okay? And the thing is to look, high depth technical artifacts. So like this is a focus, right? Windows focus. When analysing a standard computer system, which most are Windows, forensic examiners rarely look at just standard files. They extract low-level operating system artifacts to prove or to show user activity. There could be like file system, the master file table, the structural map of an NTFS drive, which is what Windows use. It retains creation, modification, and deletion timestamps to every file, even after deletion, right? Application execution, prefetch files created by Windows to speed up application launching. They prove a specific program, e.g. a hacking tool or wiping utility, was executed, including the exact timestamp. User activity, Windows registry hives, massive databases containing configuration data. Okay, shards like shell bags track exactly when which folders a user opens and viewed, even if those folders were later deleted. External media, UBS store registry key logs the vendor, product ID, and serial number of every USB flash drive ever plugged into the machine, allowing investigators to track any sort of like data exfiltration or USB connection for anything else for that matter. Volatile activity, RAM or memory forensics, captures active data lost when a window or when a computer powers down. This includes running malware, unencrypted passwords, open network connections, and active chat logs. So there's a lot of essential forensic toolkits. Analyze rely on many different specialized software platforms to automate data indexing, file carving, and artifact parsing. Things like FTK Imager, image standard for creating forensically sound, bit-by-bit disk images and calculating cryptographic images. Autopsy, or the Sleuth Kit, a powerful open-source graphical interface used to analyze disk images, view web history, and flag specific keywords. Volatility, an advanced open source command line framework specifically engineered for deep RAM analysis. EnCase and MagnetXM, premium integrates commercial tools utilized heavily in law enforcement and corporate incident response for automated evidence recovery. So then there's the threat landscape, anti-forensics. Sophisticated actors will intentionally try to complicate or delete forensic analysis using countermeasures. Time stomping, maliciously altering file timestamps within the MFT to trick analysts into looking into the wrong part of a timeline. Analysts counter this by verifying hidden system logs or the USN journal. Data destruction using secure file shredders or zero-outing unallocated space to make standard file recovery impossible. Steganography, hiding data inside innocuous files like concealing a text document inside a JPEG photo. This requires specialized signature and statistical analysis to uncover. And so, look, there's a lot you need to do if you're thinking about digital forensics, but the key thing to hear is we've got to collect the evidence. So you've got to turn on logging make sure all the system logging is on. And then you've got to examine all the logging and the memory and the disks and all that sort of stuff. Collect evidence, all right? So I'm just sort of trying to say this is a bare basic thing, and there's all sorts of areas of digital forensics you could go into. And this is not for, I wouldn't suggest doing this unless you know what you're doing, because you could cause more problems than it's worth. They do have people specially trained in computer forensics or digital forensics. So, I would sort of, you can look this more up yourself, but this is just a bare basic, okay? Thank you for your time.